So the coordinate plane, which we've seen before, looks something like this. We have 4 quadrants. They are 1, 2, 3, and 4. Always starts in the top right, and then it actually goes counterclockwise. And we use the Roman numerals, so we say 1, 2, 3, and 4. We have our x-axis and our y-axis. This point in the middle right here is called our origin. That's the point 0, 0. We also need to remember which way the positives and negatives go. If you think about a number line, if we had 0 written right here, all of our positive numbers would be to the right and our negative numbers be to the left. If you think about a thermometer, we would have our positive temperatures, and then after 0 would be our negative temperatures. So we know that quadrant 1 is positive and positive. Quadrant 2 is negative and positive. Quadrant 3 is negative and negative. And quadrant 4 is positive, negative. So some terminology you need to be aware of. We have an x-axis and we have a y-axis. A lot of people like to remember the y-axis like this. They think y has a tail attached to it. So there's our y-axis, and then we have our x. An ordered pair would look something like this. Say we had 2, 3. We know that both these numbers are positive, so which quadrant should it be in? Should it be in the first, the second, the third, or the fourth quadrant? You should have said the first quadrant, because x and y are both positive. X and y are both positive, so it's somewhere in here. In order to graph it, we would say start with our x, which is 2. We'd move from our origin 2 spaces over. Then we would go 3 spaces up, and we would say this point right here is 2, 3. Now a lot of people like to mix up which one comes first, whether or not this is x or y. They'll say sometimes this is y, this is x, or they mix them up. Okay, so what I try to say is remember the alphabet, and we say W, X, Y, Z. Well, which one comes first in the alphabet? Clearly we all know that x comes before y, so therefore x and y is the way to remember it. Oh no, science! Yeah, we're going to talk about the independent and dependent variables. We've heard these terms before in science, and usually when we're talking about an experiment, we have an independent and a dependent variable. When we're graphing, we also have an independent and dependent variable that actually tie in with our scientific independent and dependent variable. And yes, they're both holding dead things. So when thinking about the difference between independent and dependent variables, think about the words themselves. Think about independent. We know that independent means it will do what it wants or what it's supposed to do regardless of whatever else happens. Let's say you had a test tomorrow. That is going to be tomorrow regardless of whether or not you study for it. That is independent of your studying. However, dependent is your grade on that test is dependent on whether or not you do study tonight. Independent is the test itself. Dependent is your grade and your studying. So now let's tie that in with our coordinate plane. So x is our independent and y is our dependent axis. Here's a way to think about this. Time is independent. No matter what, time will just keep moving on. It'll keep going forward, it'll keep going forward. Time cannot be changed by us. However, what we do depends on the time, correct? So, if the time is moving forward, we're running out of time, we have less options. So think about moving up and down as what you're able to do, what you're not able to do. Because it depends on what the time is.